Hello, beta. Hello, 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 hello. Am I audible and visible to all of you? Am I audible and visible to all of you? Yes, that's great. Once again, so let's start lecture number third on magnetic effect of electric current. So previously we had the discussion on Biot-Savart Law, application part of that is magnetic field due to a wire, and then some cases of that finite wire, infinite wire, semi-infinite wire. Then we had a discussion on magnetic field due to the arc, right? Due to a circle, semicircle, a quadrant. So we had a discussion on these things, then how to find the direction of magnetic field. So I guess we discussed these things, right? So today we are having lecture number third of magnetic effect of current. First of all, I need to check whether the screen is visible to all of you. Okay, the last time I was just teaching something, but screen was not visible to you. Let me check firstly. Okay, now it is visible. So we will start today's class with one numerical, a very good numerical, based on the previous topic that we had concluded in I guess in lecture number first, right? So let's start now. So the numerical is like, look now. Okay, one second. Now numerical is like we are dealing with 3D. We are dealing with 3D. How, sir? Look, if one current wire is coming along x-axis, it's coming from infinite, goes towards the infinite. One wire is like in y-axis. Karthike, I guess we started this lecture series, na, whole in English, right? So the whole lecture series will be in English now. So we are having next one in this way. This particular thing means these wires are not intersecting. Second wire is in this way. Done? So we are having a point, this particular point. It is on, okay, I will just make sure it should be visible to you now. So I will make it like this. Look. Just imagine this one in 3D. In 3D. My point is here, this particular point. Imagine this one as a 3D. So you can write, so this one is x-axis, this one represents y-axis, and this one represents z-axis. Done. And current I1 is flowing in this wire, and in this wire current I2 is flowing. Now I need to find out magnetic field at this particular point P due to I1 wire and I2 wire. Now take your right hand, to get the directional things, right? Take the right hand. Okay. My I1 current is going upwards. I will just place the thumb one in upward direction. Now I need to get magnetic field here. Okay, look, one wire is in this way, one wire is in this way, and the third point is here. So current is going in this way. Current is going in this way. My point is here, so I need to go like this now. So look, my palm is towards right axis, right x-axis. So I can write here, sir, my B1 is magnetic field due to I1 current would be in right axis. Done. Now, in the same way, I will take my right hand. Okay, wire is in this way. This is my wire. Okay, my point is here in space. So I2 current is going in this way. Done. And the point is here. So it will be like this. So B2 will be downwards. Okay, it would be downwards. Done. So it is downwards. B2 would be downwards. So I will write now B1. What is B1? So these are infinite wires. I can write it is nu naught I1 whole divided by 2 pi. Distance means that is about D. No issue. Okay, what is B2 now? B2 is nu naught I2 divided by 2 pi D. Two vectors. These are two vectors now. One vector is in this way, one vector in this way. Vector A, vector B, both are at 90 degree. So if you need to get the resultant, it would be like this, no? Resultant vector. That would be A square plus B square plus twice A, B cos theta root. Theta is 90, so cos 90 would be 0. So this term will become 0 now. So my resultant would be only A square plus B square root. So can I write here now the net magnetic field? It would be equals to B1 square plus B2 square. What is B1? Nu naught I1 divided by 2 pi D whole square plus nu naught I2 divided by 2 pi D whole square. We have the root. So I will take nu naught divided by 2 pi D common. Then we are left with I1 square plus I2 square. And this is my net answer. This is my net answer. A good application of our numerical practices, right? Any confusion with this particular numerical? If you have, you can just ask me now. If not, then we can just shift towards a more difficult one. Look, in this numerical, we are only discussing the magnitude. In next numerical, we will be discussing magnitude with direction. Okay, now, next numerical. Next numerical. Next numerical, like, same way, we are having, look, this is my x-axis. Infinite x-axis. My y-axis, infinite y-axis. Then we are with one more axis, that is z-axis. Done. So now current I1 is flowing in this one. Current I2 is flowing in this one. Or for simplicity, I will write I on I only. Done. And one more thing, that current I is also flowing in this one. There are three axes now. X, that means this is plus I cap. This one is minus I cap. This one is minus J cap, plus J cap, plus K cap, minus K cap. Now my point is here. This one, point P. We need to find magnetic field at this particular point P. We need to find magnetic field at this particular point P. So how we are going to find out the magnetic field at point P? We will break down this 3D structure in 1D, 1D. How, sir? Look now. First of all, we will take this one. Take your right hand. Okay, sir. Now look, imagine my wire is going in this way and point is here in minus K cap now. That means inwards. Okay. Take your right hand. Place your thumb in the direction of current. Then you will find now direction of my hand of palm is upwards. Now, if we talk about B1 now, if we talk about B1, I guess by this doing, my B1 comes out to be in this way. That particular direction means plus J cap. Second one, my current is J axis is going in this way. Point is here. Place my thumb, direction of current, open my hand towards the point P. Now palm is in left side. Left side means minus I cap. I can write B2 now. If this is 1, this is 2, this one is 3. Then B2 comes out to be in this way, and this one represents minus I cap. B3, you can see now current is flowing the same direction, and we are having point P on the actual position, and we done this thing. Sorry, if the point is coming in on the actual point of any wire, magnetic field is 0. So I can write magnetic field due to the third wire is 0. Hello, beta. Now, what we need to find? Sir, we need to find out B net. So I can write here B net. B net means the net effect of all of them. So I can write B1 plus B2 in a vector form plus B3. What is B1? This is due to the infinite wire. But I will start 11th in next month. And before your examination, I will conclude your 11th also. Okay. So what is B1 now? We know that it is nu naught I. I current is same flowing throughout all these wires divided by 2 pi d. I can write 2 pi d. Distance is same. Now you can see first one is plus j cap. So I will write here plus j cap. Plus what is B2 now? Same nu naught I divided by 2 pi d. But this was in a minus I cap. Third one is 0. So I guess I will take one thing common, that is nu naught I. 2 pi d I will take common. Then what I have here, it is j cap minus I cap. This one is my answer. If you are having any issue with this one, you can just let me know. Good numerical. And you need to be very good with manipulating these numericals, right? But every time you don't get the simple numericals also. Previous one we discussed it with the magnitude. Now this one with the directional properties thing and the vector one also. Done? Okay. Let us do one more numerical. One more numerical. You will get a lot of numericals in my class. So we are having a numerical. Okay, look now. My numerical is like so this thing represents from this particular point to this particular point, it is a finite wire, and this distance comes out to be r. Done. Current is flowing in clockwise direction. I need to find out magnetic field at the center. Okay. So this graph, okay, if I will give one more thing, that is angle. Okay. This angle is phi. So this angle is also phi. I need to find out magnetic field at the center. How I can get it now? Look, if it was a circle, then it was easy for me to get it now. I know the thing done, but it is not a circle. It is a part of a circle. So I can write this one represents arc. This is a arc. And this one is a finite straight wire. Finite straight wire. So if I need to find out magnetic field at the center, I need to find out due to the arc, then due to finite straight wire, then I need to add both. I will get my answer. Okay. Now, what is magnetic field due to arc? Okay. Magnetic field due to arc. What is the formula for that? Any guesses? I guess it is nu naught I divided by, it is 4 pi r into alpha. Alpha means the angle. So this one represents the alpha. This one. Look, the whole angle is 2 pi. So I can write now it is 2 pi minus 2 phi. Why, sir? Because look, whole is 360, 2 pi. Now we have to subtract it with the phi. We have 2 phi now. 2 pi minus 2 phi. And you can take the right hand. It is inverse. So I can write now. Sir, nu naught is same as nu naught I, and alpha is 2 pi minus 2 phi. It is 4 pi and radius is given as r. Radius is given by r. Done. So it is inverse. So cross means inverse. Now due to B2. B2 means due to straight wire. So formula is nu naught I divided by 4 pi. Then we are having r. Then what we are having now? It is sine theta 1 plus sine theta 2, and this one is my general formula. You can see here, so I have nu naught I as it is 4 pi. What is r? R simply indicates distance of your wire from the point. So it is not this one. No, it is not this one. No, it is this one, straight one. Okay. If this is r, so I guess this one comes out to be r cos theta. Yes, this one comes out to be r cos theta. So what I can write here now, it is nu naught I, and sine phi, theta 1 is also phi, theta 2 is also phi, sine phi plus sine phi divided by r. Instead of r, I will write r cos theta. Done. Okay, now it is nu naught I divided by 4 pi. It is not theta, no? It comes out with phi here. So it is phi. It is phi here. I will write now, it is 2 sine phi divided by r cos phi. Done. Okay. Now what I can do from here? 2 to the 4. Sine by cos is tan. So I can write nu naught I divided by 2 pi r tan phi. It will be also inverse. And what is B net now? It is B1 plus B2. What is B1 now? I can take 2 common, so I can write nu naught I divided by 2 pi r Then I had to take 2 comma, it is pi minus phi, it is plus nu naught I 2 pi r tan phi. And both these things are inside, inwards, cross. What I can do, I can take something common also. What, sir? I will take nu naught I divided by 2 pi r common. Now I am left with pi minus phi plus tan phi. And this is my ultimate answer. Done? Done, beta? Any confusion? Any confusion now? If you have, you can just let me know. No confusion? A good numerical, no? A good numerical. Okay. Let us do one more numerical. One more numerical. A numerical like if we have a square. Square. Now square with side A. With side A. I current is coming, I current is going. Then we need to find out magnetic field at the center. What could be the possible answer for this one? If you knew this one, I guess we discussed this one in the last class. If we are having a regular shaped polygon and current is getting distributed, right? So the net magnetic field at the center would be 0. It is simple. So magnetic field at the center due to these things are 0. Done? Done now? Okay, look now. I have a couple of numericals more. 1 second. Let's do some numerical. Then we are having a couple of things pre-written. Then we can discuss those things also. Suppose we have a system. Suppose we have a system. Initially current was I, then we changed current to I from then to I. Initially number of terminals was n, then we changed the n to n by 2. Initially magnetic field was B. Okay. Now we need to find out the new magnetic field. How we can get it? Okay, sir, I guess, look, this is a real case of a spiral thing or a circular thing. That's why we are having a couple of terms for that also, no? Yes, sir. So I guess the formula to get the magnetic field at the center, it is n times nu naught I divided by 2 times R. Is this my formula? Yes, sir. We have n, done, current is I, done, and this particular thing represents B. Okay. Now we changed n to n by 2. Nu naught as it is nu naught, current as 2I. Now everything is same, that is 2R. Then this one is B dash. Let us divide these things. You can see now n cancel out. This one cancel out. I cancel out. 2R cancel out. So from this thing, so we got to know that is B divided by B dash. It came out to be 2, 4. Clear? It is 2 cancel out. It is 1 by 2 then. 1 second now. Cancel out. So I guess you can see now. You can see now. These two cancel out. So it is same now. It is 1 by 1. Therefore, my initial magnetic field is equals to my final magnetic field. This is my answer. Done? Clear? Okay. Let us do a one more numerical. One more. That is, look now. What the numerical is all about. Look, beta. Okay, this is my numerical. So I guess this numerical is visible to you. Okay, this one is visible. And what this numerical is all about. So two long parallel wires. You can see from the language that two long parallel wires. Long means infinite. Okay, simply means infinite. Infinite. Carrying current I. In first one is I current, in second one 2I current. Direction is same of the current. Magnetic field just between the wires is B. Done, sir. If now 2I current is switched off, then magnetic field at the same point. That means if we are having two wires, wire first, in this wire current I is flowing. Wire second, in this wire current 2I is flowing. 2I. Done. If the distance between them is A, usually we are taking A, you can take X, Y, whatever thing you like. Okay. If this one is my middle point, so this distance could be A by 2 and this one is A by 2. Okay. So here, if you can take right hand, so B1, the first one, if this is first wire, second wire. So I will take right hand, so B1 would be inwards. Okay. And B2 would be outwards. What is B1 now? Infinite wires, nu naught I, 2 pi, distance is A by 2, and this one is inwards. B2, nu naught I, sorry, 2I. Nu naught 2I divided by 2 pi A by 2. What is B net now? B net. I guess it is B2 minus B1 now. Why? Because B2 is more than B1. Dot. B2 is more than B1? Yes, sir. So I will write now nu naught I, 2 cancel out. 2 cancel out. It is nu naught 2I. B2 naught is nu naught 2I. Nu naught 2I divided by pi A minus nu naught I divided by pi A. I will take nu naught I by pi A common. We are left with 2 minus 1, that is 1. So my B net in first case came out to be nu naught I divided by pi A. Done? It is first case. Now in second case, it's talking about now if now 2 1 is switched off. That means we are only left with one wire. Wire firstly current I is flowing and we are having distance A by 2 as per the requirement. A by 2. So what is magnetic field now? Sir, nu naught I1, that is I divided by 2 pi A by 2. Cancel out, so it came out to be nu naught I divided by pi A. So you can see now the final magnetic field at the initial both are equal. So I can tick on the option number 2. Option number 2 is correct for me. Done. Okay, now let us do next numerical. Next numerical, this one we are completed with now. This one now. One second. Okay. Second numerical. Second numerical state is that what we are having now. We are having okay, magnetic field at point P. So at this particular point P, I guess it is visible to you here. So I will make it here point P. So here point P, I need to get my magnetic field. Take your right hand. We are having two wires. Long wires meaning infinite wires. One wire and second wire. First wire, second wire. Magnetic field at point P due to first wire. Take your right hand. Take your thumb towards the direction of first current. And towards the P, open your fingers. I guess palm is inside, so magnetic field is inside. So magnetic field due to first wire is inside. Done. Same. Take your hand, take the thumb towards the direction of current 2. Done, sir. Take, stretch your fingers towards the point P. Now palm is inside. So you can write B2 is also inside. So if, look now, this one is wrong. Why, sir? Dot. This one is wrong. Now we are left with two options. We are left with two options. First and second. Then, so look now. So I guess my B net. I guess my B net in this particular case, I will write as a B1 plus B2. Okay. What is B1 now? Simple. It is nu naught I by 2 pi d. It is nu naught. First case I. What is I? Sir, I is 5 ampere divided by 2 pi. 2 pi d. What is d? I guess d for first wire is this one. Okay. 5 plus 2, 7.5. It is 7.5. It would be 7.5. Done, sir. Plus B2. What is B2 now? Nu naught 2.5 whole divided by 2 pi d. From this one, it came out to be 2.5. So it is 2.5. Done. 2.5, 2.5 cancel out. So I will take nu naught divided by 2 pi common. So what we have 5 divided by 7.5 plus 1 only. Done, sir. I will write nu naught divided by 2 pi 5 plus 7.5 divided by 7.5. Okay. Look now. So B net is equals to nu naught divided by 2 pi. So what we have here, we are having here 7 plus 7.55, it is 12. 12.5 divided by 7.5. Then point cancel out. It is 5 on the 5, 5 5 25, 5 is 2 the 10, 25. 5 3 is 15, 5 5 25. It's 5 by 3. So B came out to be 5 nu naught divided by 5 3 to 6. It is 6 pi. And it is cross. Which one is correct now? Option number second. So option number second is correct. Done? Easy or super easy? Asana beta, I am not getting your response, right? Be attentive in the class and be the responsive. Okay. And I can see the only one student from my previous classes. Am I lagging? One second. Am I lagging? I need to check it out. No, it's good. Okay. One more numerical now. If these are very easy for you, so I will just give you one more numerical then. Okay. With one numericals, the level of hardness will increase. Done. This one now. Okay. Now, numerical is like for given current distribution, each infinite, you can see here, each infinite length wire, nu naught I, 2 pi d, produces magnetic field at B at origin, then resultant magnetic field at O. So where is O? I guess this is my O point. Okay, no use, sir. Look, this cross represents it is this wire is going inside. Dot means it is coming outside. Means if this is my pen, current is going inside means I can represent it with the cross. If it is coming up out from the plane, so it is dot. Okay. And if it is cross, you can take your hand. It is cross, so magnetic field would be where? You can take your right hand. Take your right hand. Place your thumb inside the plane. I guess at the O point, you can see your palm is going upwards, so your B will be upwards. Okay, if it is 1, so my B1 is upwards. Done. For this one, second one, take your right hand. Done. Your current is going outside the plane, so take your thumb outside. Stretch your fingers towards the point P. I guess B1 is right side. B2, sorry. B2 coming out to this side. Third one, take your right hand, current outside, and I guess my B3 is also upwards now. Yes, upwards. Fourth one, take your right hand, I is inside, it would be rightwards. So B4 is rightwards. You can see here, current is I, current I, current I, current I. Distance A, distance A, distance A. That means each and every distance is same. So can I write now B1 is equals to B2 is equals to B3 equals to B4 only in the magnitude terms? Okay. Then can I write now B1 and B3 upwards? Can I write it is 2 times B? B2, B4 rightwards, I can write 2 times B. Now two vectors at 90 degree, so their net would be like this, it would be B net, and B net would be equals to 2B square plus 2B square, it is root now. I will take 2B common, so we are having then a root 2, right? I guess my answer 2 root 2B. I guess option number 3 is my correct option. Option number 3. Easy or super easy? Easy or super easy? Huh? You can just note down these numericals, right? If you don't have that much of time, no, do join my Telegram group then. Shukur Sir Physics. There at the end of the chapter, I am posting or I am uploading the PDF of my notes. Okay, now one more numerical. If your basics are clear, na, then each and every numerical is very simple then. One more numerical here, this one. Okay. What this numerical is all about, you can read it. The position of a point from B. B means, okay, this one. From B where, okay. Where the net magnetic field is 0. Okay, null point due to the following current distribution. It is null point, no? Okay, sir. Okay. So we know that if we are interested in finding the null point, we need to find from the lower one. Here 2I, 5I current. It is 2I is less, so my magnetic field null point will be closer to the lower one. I can write, sir, this distance I can write as x. So this one would be here 6 minus x. Now here magnetic field is 0. Can I write now B is 0? It would be 0 when B1 equals to B2. Okay, sir. So I can write B1 equals to B2. What is B1? Nu naught I. What is I? It is 2I. 2 pi d. 2 pi d. What is d? D is x. X, okay. Equals to nu naught I. What is I? It is 5I. 2 pi d. 2 pi d. What is d? D is 6 minus x. 2 pi cancel out. Nu naught cancel out. I cancel out. I can add 2 to the 12. It is 12 minus 2x equals to 5x. Then 12 came out to be 7x. So x is equals to 12 by 7 centimeter. 12 by 7, option number second is correct one. Yeah, I usually hear the null point concept, you know. Which previous setup? Which one, beta? HDJ, which one? Your name is something different, right? Which step you want to get repeated? Which one? Yeah, you are on the right track now. You can use null point concept here. Okay, previous question, last step. Okay, this one. How it come out to be 2b root 2? This one, beta. I guess this thing is clear to you now. That's why you're not asking to repeat it, no? Okay, done. You are not asking for anything, that it is clear to you now. Okay, now one more numerical, then we shift to the NEET concept. This one is done. This one now. This numerical. Okay. So this numerical is about two concentric. We are having two concentric coplanar coils of terms N1 and N2. Two concentric coplanar. Okay. Radial ratio is 2:1. That means R1 by R2. Equal current is equal current in both the coils. Okay. In opposite direction. Okay. Two concentric coplanar coils means we are having coils in such a way that their center coincides. Okay, no issue. Done. Okay, sir. Look now. If the radius of inner one is R1, radius of outer one is R2. If the current of inner one is I1 or I simply, outer one is I in opposite sense. It is given in the numericals only. And R1 by R2, it is given to us as a 2 divided by 1. We have to find out N1 divided by N2. This thing we need to find out. Look now. Look now. How we can do this numerical? Okay. Look better. If we talk about the first one, this one, no? First one. My magnetic field at the center, it would come out to be outward. So B1 is outward, B1. And if we talk about this one at the center, B2 will be inwards. B2 is cross. Done? And it is shown that net magnetic field is 0. If net magnetic field is 0 at the center, then I can write here only one relation is possible, B1 equals to B2. B1 equals to B2. Okay. What is B1? I guess it is n1 times nu naught times I divided by 2r only. It is 2 and we are having r1 equals to n2 nu naught I divided by 2r2. Now see here, nu naught I cancel out, 2 cancel out. Therefore, n1 divided by n2 is equals to here r1 by r2. So r1 by r2 is 2 by 1. So therefore, n1 by n2 is also 2 divided by 1. So option number 1, A is correct. Easy or super easy? Okay, but the right thing is you need to get your numericals, approach it click in a seconds, and it's going to be very easy to you. Then, okay, now let's start now. One more application part of Biot-Savart Law. We are just using these things. So the next application part, I guess it is third application part of Biot-Savart Law, that is magnetic field on the axial position of the ring. So what is axial position? Axial position means, suppose if we are having a ring like this. Now look, it is my ring. If this is my ring and my current I is flowing through the ring, if current I is flowing through the ring, and the radius of this ring is r. Now center, if I just place a line perpendicular to the space or area of my ring. So here, if this particular point is x distance apart from the center of my ring, so at this particular point, I need to find my magnetic field. So first of all, let us suppose I will take a small current element, small current element, ideal, right? Now I need to just connect the current element with my particular point. If this angle is theta, take your hand now, take your hand for directional properties. So if current is going in this way, current is going in this way, it is, if we are seeing from this perspective, it is anti-clockwise way, it will be dot. So I will place my hand in this way, okay, it would be, so if you place like this, it's slanted height now. So my B, this would be my dB, small element. Look now here. Look here now. Theta, this one would be in 90 minus theta. These two are in 90, so this could be theta. If this one is dB, so this would be dB cos theta. And this one would be dB sin theta. I will take one more element, this one, this element. One more element here. Same, we will be having dB here. Same theta and theta. This could be dB cos theta. This one is dB sin theta. So you can see now the net effect would be rightwards. dB cos and dB cos cancel out. So if you need to get dB, net magnetic field, it is a derivational part. It is wholly a derivational part. Okay. So my dB, it would be by Biot-Savart law, it is nu naught 4 pi, it is constant. Then what we have, it is I dlr sin theta divided by r cube. 1r cancel out. This is r. You can see now the angle between these two is 90 degree. It is always. Okay. I will write it is nu naught divided by 4 pi I dl sin 90 divided by r. If the base is x, perpendicular is r, so my hypotenuse would be, it is x square plus r square root. I will place here x square plus r square root. Sine 90 is 1. So dB comes out to be nu naught I dl whole divided by, no, we are having r, it is r square, also here it is r square. No, I just r cancel out, so no need to r square. So it is 4 pi under root of x square plus r square. But I don't need dB, I need b, so I will integrate it from 0 to 2 pi r. Sir, why 2 pi r? Because I want whole circumference of circle is 2 pi r. Okay. So now dB is as it is dB. Nu naught constant, current is constant, 4 pi is constant. Done? 4 pi is constant. But I guess it is, look here, no? I guess I had just missed something. Ideal, it comes to be r square. If r square will cancel out, but now I'm pretty sure we had done something wrong here. R, I guess we had done something wrong here, no? Huh? IDL r cube, r square is r cube. Where we are just messing this up. Any idea from your end? No, this one is r cube, no? Look, it is r cube here. R cube, upper side ideal cross r. Okay, yeah, this is r, not this would be capital R. Capital R. So here we are having r. So it could be 3. Thrice. It could be thrice. Here we are having r now. So I can write nu naught I into r. So we are having x square plus r square. We are having 3 by 2. It is 3 by 2 constant. Integration of, we are having r dl. Integration of dl. So okay, here it is b only. B only. So I can write b. Nu naught I r 4 pi x square plus r square 3 by 2. Integration of L, it will be 2 pi r. Pi cancel out. 2 ones 2, 2 twos are 4. So my b came out to be, it is nu naught I r square whole divided by 2 x square plus r square 3 by 2. Done? For one loop. For one loop. But if we are dealing with n number of loops, then I need to multiply it with the n. So I can write it b equals to n times nu naught I r square divided by 2 x square plus r square 3 by 2. Okay. Now let's manipulate these things now. How, sir? Look now. Look here. We can do one thing. It is b at the actual position, no? On the actual position. I can do one thing here. Look, it is nu naught I r square 2. I will take x square common. So it will be x square 3 by 2 1 plus r square by x square 3 by 2. I will write nu naught I r square divided by 2 to cancel out. It could out to be, I guess, no, r by x, over we are having x. It is not like that. I need to take r, I need to take r common, not x. One second. I will take r square common. So here it is not r square by x square, it will be x square by r square. It would be x square by r square. Perfectly all right now. I can write 2r cube. Then we have 1 plus x square by r square. Then 3 by 2. Cancel out. It is nu naught I divided by 2r. 1 plus x square r square 3 by 2. R square 3 by 2. Okay, now tell me what is the magnetic field at the center? Is it nu naught I divided by 2r? Okay, nu naught I 2r. Therefore, what I will write here, therefore, B axial point equals to B at the center of the ring divided by 1 plus x square divided by r square 3 by 2. One more formula that you need to remember. Okay, we can manipulate it also, no? How, sir? Let us suppose my x is more than r. It could be. Suppose my x is more than r. What you can write now? Sir, if my x is more than r, so I can write 1 plus x square divided by r square is approximately equals to x square by r square. Approximately. I can write B axial equals to B center divided by x square by r square, that is 3 by 2. I can write it as a B center divided by x divided by r square, then 3 by 2 to cancel out. Therefore, B axial equals to B center divided by x by r cube. So from this perspective, we conclude that B axial, if it is very long, it changes inverse 1 upon x cube. This is a relation that it follows if my x is more than r. Okay, every time it is not compulsory that x is more than r. We can write then, let's suppose my x is very less than r. Suppose it could be answer, no? One more thing, that my x is very less than r, very close to r. B axial equals to B center divided by 1 plus x square divided by r square 3 by 2 equals to B center divided by, I will take it upside. So it becomes now B center 1 plus x square divided by r square minus 3 by 2. We know that 1 plus x to power n is equals to 1 plus nx if this is very low, if x is less than 1. It is very less than 1. So now from this formula, I can write that B axial B center 1 minus 3 divided by 2 x square by r square. One more formula. Okay, this is nothing, no? It's replacement of the formulas only. Then, if somebody will ask you what is the change then? Change, a fractional change. What is fractional change? A numerical from fractional case once asked in the AIMS examination, that's why I'm just telling you. Fractional change means it is change in magnetic field divided by original magnetic field at the center equals to center minus axial divided by center. So what is BC? Sir, BC as it is BC. Axial, what is axial now? This one is axial now, my? Okay, it is BC. 1 minus 3 by 2, it is x square by r square whole divided by BC. BC cancel out. 1 minus 1 plus 3 by 2 x square divided by r square cancel out. So therefore my answer came out to be delta B by B as center came out to be, it is 3 by 2 x square by r square. X square by r square. This one is our answer. Okay. Now If we need to make a graph for it, a graph, this is my graph. Maximum, maximum is at center. When my x is 0, so B is at maximum point. This one. Okay, done now. Then it will change in this way. In this way. So my BC and this is my maximum value. We are having two values here. Two values. Important values here now. Minus R by 2 plus R by 2. These are values at where your graph changes its nature. Look here, until this point, it is parabola. Then from this particular point, it is hyperbola. Okay, parabola, hyperbola. That's why this point, which changes the structural things, parabola into hyperbola or hyperbola to parabola, it is point of, I will write here, point of inflection. Point of XION. No, it is XION. XAION. It is not important now to remember these things, but yes, what the point is all about, you need to remember it. That is the one last numerical of today's class. Then we can just wrap up the whole one. One last numerical, I guess. Yeah, last numerical. Okay, this numerical is from this the fractional decrease one. No? States that a radius of a current carrying coil is R. Okay, radius is given. Fractional decrease is fixed in a fixed value with respect to center of the coil for nearby actual point is 1%. Fractional decrease is given. So what does that mean? It is delta B by B center, it is 1%. Then find the actual position of that point. X we need to find out. Okay, so no issue. I guess delta B by BC, we conclude it is 3 by 2 x square by r square. It is 1%, it is 1 minus 100. 2 minus 250, sir. It would be 50. I can write x square equals to 150. 1 second. No, it won't be like this. X square equals to r square divided by 150. So x came out to be r divided by under root of 150. This could be my possible answer. And with this numerical, we conclude today's class. If you have any doubts or if you have any confusion like that thing, you can just ask me now. I will wait for a couple of minutes. If you don't have any answer, if you any confusion or anything like that, then I can just end the class. Done. No confusion. Okay. So just do your homework, your DPPs from any of your institutions, right? Then do your module. And if you find any confusion or if you have any issue or anything like that, you can just reach out to me. You are having my Telegram ID. Okay. So for tonight, bye, beta. Bye. Good night. Thank you. Bye. Thank you. Bye. Good night.